Hi guys, welcome to another code film. In this code film, we are going to look at callbacks and asynchronous services, and this has to do with enterprise solutions. We are still using the Java language, and it's a backend development subject. So I would like us to just first of all understand what the whole concept of callbacks and asynchronous services is, and why do we even need callbacks, because some understanding of that is not really available on the internet. So this is my special version, or my special addition, or my special contribution to the technology world in regards to callbacks, asynchronous services, and enterprise solutions. So let's just go straight into it. So the first question you ask yourself is, why do we need callbacks, and also why is there development of asynchronous services? Well, there are some network principles that influences data processing, or the transformation of data to reliable information, or the passing out of data to become meaningful objects. And one of those principles is network principles. When I talk about network principles, if you are someone that has a little bit of technical background, you understand that when you see such a diagram, it tells you that we have a network in place whereby data is being sent back and forth, or to and fro, from one computer or one server or one device to another device, and it's all happening at once. So if you take this computer network for example, we have a user of this machine who is trying to send some data from his laptop to another laptop. It could be from this device to a device here, or from that device to, or talking to the server. This kind of information relay that takes place can experience some form of latency, whereby latency means the time that it takes for data to move from one end to another node and return. So that's network latency. So regardless of how our network is being connected, sometimes we can experience latency, and there are a lot of factors that influences latency. It could be the location of the service that houses those data. It could be the volume of data that is being transmitted. There are so many factors that influences latency, and so because of network latency, we have to build services or implement solutions that have respect, or that regard asynchronous processing, or that regards the use of callbacks when our information is ready. So this is just the understanding that network principles does affect callback. So this diagram helps you to understand how information can be relayed from one computer to another computer, passing through a complexity of networks, which can experience which can be affected by several factors: high volume of data, location of network traffic, could even be the slow internet provider. So many things can occur. Alright, now the other principle that affects callbacks and asynchronous services or solutions is database principles. If you are someone that has worked with database, there's a key principle that influences databases. That's the asset properties: atomicity, consistency, isolation, and durability. If you take a database query for example, each and every transaction or statement takes place at once, or it doesn't happen at all, and that's the key point I want us to take. So because we are trying to get information or data from our database, we execute them in statements, whereby we hit a statement, then we wait for a response. We hit a statement, wait for a response. So that kind of processing is kind of synchronous. Synchronous. Well, you execute, you get a response immediately. Well, it does take some time, but it will definitely come. It's not something that's asynchronous. You do get a request and you do get a response, and it's a transaction. It's an atomicity, because each and every statement takes place in its own atomic shell, in its own its own line. It's not um it's non-atomic, it's atomic in nature. So let's move to this query and let's understand what I'm trying to say. So let's pick this start a transaction. So when I'm starting a transaction, I have my queries that I'm going to run. So I'll select start from the merchant, just get all merchants. I want to look at the properties of the table. And a good example is when I want to do an update to the table. As I'm updating this table, to change the build type to a variable build type using the merchant ID. Until this is done, if I do a select to it to find out if the changes have been done, without making after doing these processes, like doing the update, and I do a select, I'm expected to see the results of that. Then if I do a final commit per this user or per this session, everything will be updated. So I do first an update which will take place, then I do a select, and I'll do see the changes. I'll take you to the database for us to understand what we are doing. So it all takes place in atomicity. So based on the objects that you have in your database, there are sometimes that the information you want depends on another action or another event from another person. Example is, let's take example, the example we'll be using our demo will be that of food ordering. Let's say you order for food, you place your order. Once you place your order, it goes to maybe a back service or the catering services that you are requesting an order from. Let's say you are using a food ordering app. Once it gets to them, as of that time, it's going to be pending because your order has now yet arrived. So you are now going to look at it. So in our database, we will change that status to pending because we are now going to look into your order. Then when we are done with your food and everything is done, then we will then send a response back to maybe the delivery company that wants to deliver your food that the food is now ready, so that they count for the food. So that kind of processing is we need a callback, or we need some form of asynchronous solution. And the reason is because of the atomicity principle that affects databases. So those are the two main reasons why you need to design systems with a callback or asynchronous services. So now before we get into our demo, which we'll be looking at later on, what is a callback? A callback simply is to return a call. A call has been made already, then you want to return the call. That's a callback. And then the asynchronous is, once I make a request, I wait till I get my response. Once I make my request, I don't wait till I get my response. I hit my request, then when the data is ready, the response will be sent to me. So that's the difference between synchronous and asynchronous. Synchronous, you do hit a request, you get a response. But with asynchronous, you send your request. When the response is ready, it's sent to you. So we are going to be looking at this in-depthly with solutions and with some answers. So as it stands now, this is the whole understanding of callbacks and asynchronous services. If you have any questions, do drop it in the comment section. But before that, let's just I promised I was going to look at this. Let's just look at this sample query to understand what I'm saying. So I'm going to swing to my SQL console, my SQL community shell. Okay, slowly. Okay, so I'm just going to copy that query and I'll open another connection. Let's have another connection open. Alright, so let's go and look at that query and let's just write the same thing here. Sorry. So we are going to use the SAMPay database. First of all, let's see if auto commit is available. Auto commit is a feature that helps us to check what is available on the internet. sorry, what is available in your database as whether the commit is on or not. So auto commit is on, meaning that once I hit a transaction, it will be updated automatically, like it will be committed automatically. So first I'll start my transaction and I'll change auto commit to 0 because I don't want that to be the case. I'll do a select star from QR merchant and then update. So first let's look at the select statement. So let's first set auto commit to 0. Auto commit to 0. So set auto commit to 0. Alright, then let's do the select. Okay, so it's 0, so let's do a select star. Alright, so you do see everything. Now let's pick a particular record where merchant ID is equal to 67455. So this is the record that we've gotten from our database. Okay, so with this record, this is what we want to do. We want to auto commit is 0, so we want to do an update. Let's say we want to update the QR merchant's name. Update QR merchant, set let's change the terminal ID. Yes, updated this terminal ID. Let's change it to maybe 1 2 3 4 5. Set terminal ID where merchant ID is equal to okay, so let's do this. So set auto commit is 0, then we start a transaction. Because auto commit is 0, we are going to start a transaction. So set auto commit to 0. It's done. Now we start a transaction. Alright, so this our transaction has started. Then let's look at this. Let's do a select. We have the record. So we are changing 67744 merchant ID's terminal to 1 2 3 4 5. Let's do the update. Okay, let's use, because we are not using a column that has a primary key, that's why we're having this. So let's change that. Set SQL save update to 0. Alright, now let's do that again. Alright, so we've done the update. Now we started a transaction. So let's be inclusive and see if the changes have been made. Alright, so 1 2 3 4, that's good. So now let's go to a different connection and let's pass the same query and see what's in that connection for that user. Okay. Alright, so you see in this connection, because we're having here hit the commit, the merchant ID is still showing as 17870. So this is the atomicity, consistency, isolation, durability principles of the database that is coming into play. Now let's come back here and let's add the commit to it. And let's hit the commit. So now it has been committed. So if I do come here now and I do a select, I'm supposed to see the changes. Voila, that's 1 2 3 4. So this is just a basic understanding of the ACID principles affecting the database. So when we do start a transaction, each and every query runs in its own atomic state. So it runs this single statement, and that's restarting a transaction. So the keyword is transaction. So that's that atomicity. So we are running this query. So as I said, based on the object you be storing in your database, you will definitely be using some of these principles to work. So it depends on your creativity and you understanding what comes into play when we talk about the ACID principles. So That will be it for this code film. In the next code film, we are going to look at some demonstration about callbacks and asynchronous services, but this is what influences it: the network principles, as we've explained rightly here, and also the database principles, as we've just looked at. Thank you so much for your time, and then if you have any questions, drop them in the comment section. Yeah, we'll see you later. Thanks.